What are you going to do?
Ah. Sorry.
Should I not start?
I see them moving. I'm gonna record you today.
Don't.
No. They're gonna put you in this stress. Oh, you're stressed.
I am a little bit stressed.
Relax.
Because I see one of my exes in the crowd.
Ah,
I see one of my exes in like the crowd.
it's okay. Hey, you're gonna be very good. Like usual.
Like usual.
Yeah, spontaneous.
If you do click a picture, click it. Hello, hello, hello. Hi, San Francisco. How is everybody doing? Hope the pizzas have sufficed and you feel better after eating something. Thank you for coming. I see some of the familiar faces again. Very glad to see you back, and some new faces, so welcome. My name is Sonam. I am the chapter lead for AI Camp for the SF Bay Area chapter. I have my team here, Hamza, Yan, and Abid, and they are wandering here and there. So, all right. So let's start. Before I get into talking about what is AI Camp and who we are, let's get some logistics out of the way if that might have confused some of you. Trust me, it confused me when it started today. So if you have registered at the AI Camp page, you're going to see a check-in button. I can show what website, where you can find. You see the check-in button right there on the right corner. That's when you click check-in and you enter this exact code. I'm gonna give 10 more seconds so that you can check in. Or scan the code, QR code, because guess what? I have 2 free gifts, which is a wireless headphone. I'm sure any of you would like. So please scan the QR code, share it on LinkedIn, comment on the post, and then towards the end of the event, I am going to run a raffle / lucky draw, and 2 of you will get those prizes. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ta-da! Okay, so who is AI Camp, or who are we? We are basically a nonprofit organization who we are trying to connect AI developers and AI enthusiasts across the globe. And over 300,000 AI developers in 150 plus countries, we are trying to get them all together through various different ways. And so far, we have numerous local community chapters. As you can see, all those red pins, they are really true. We have some communities there. And we not only do different kinds of meetups, but we host virtual seminars weekly on Fridays. Oops. Then we have a bi-weekly AI meetup that we started from this year, which is one of them is this. The other will be in Microsoft's office, which is on March 14th. More details you can find on the AI Camp website. We do some AI workshops, boot camps, and of course, we are very interested in resuming the hackathon. So if your companies are interested in doing a hackathon with us, please reach out to me or Bill. And the other ways to get involved in the community, you can submit talks to speak. And of course, please find some sponsors if you want to sponsor the events, the more the merrier. Better pizzas, better drinks, more pizzas, more drinks, and sometimes even good prizes. And other way to collaborate is co-hosting events with AI Camp. And if you didn't catch all of what I just rambled, please write an email to us at info@aicamp.ai. Huge thanks to all our clients so far and the sponsors. This is a very colorful slide, which makes me very happy. Please, if you want to add your name, there's a chance. I want to make a community shout out. If you guys are hiring for any relevant jobs, if you're looking for such jobs or project collaboration, even co-founders, I'm going to give 3 people a chance to speak up. And I'll give you a mic to talk for 30 seconds. And I see first contender here.
Hi, everyone. So we're a semiconductor software as a service startup based here in San Francisco. We've just finished our MVP, and I'm looking for a couple of full stack developers urgently. And we're pre-seed, so we're right here in San Francisco. Oh, it's called Chip Hub. So www.chiphub.com.
Thank you, Aftab. Anybody else? Okay, I can't reach. Jan, could you pass on the mic, please? Oh, okay.
Hi, my name is Edward. My daughter is graduating from UCLA this June in data science and AI. I'm here to try to help her get her first tech job. I have resumes on the white table.
And some chocolates too. So
any help will be highly appreciated. Thank you.
Who's next? Okay. Just have to press the button.
Hello. Okay. Zoom Info, the company I work for, is looking for a finance solution architect. If you have experience in SAP at a B2B SaaS company, we're looking for you. It's not necessarily AI right now, but there is huge opportunity to use AI and combine it with finance knowledge and provide value to the internal company folks. So finance solution architect, I'll be around, hope to talk to you if anybody's interested.
Thank you. I have one more. Could you actually pass the mic to your back? Thank you.
Hello. All right. Hi, guys. My name is Gustavo.
It's
All right. Now you guys can hear me. So I created. So I created a chat bot for Wix.
Could you ask Kyle to see what's the mic situation there? Thank you. Sorry about the technical glitches. All right, I'm going to move forward. And if you didn't get a chance to speak up today, please join our Slack or Discord channel and share it if you're hiring, looking for a job, etc., etc. Thank you. And a huge, huge thanks to our sponsors for this event. Of course, GitHub for this lovely venue, and Upstage, who we will be hearing from very soon. So what talks do we have today? I'm going to make like a very small word cloud. We have LLMs, no surprise. We have Gen AI, again, no surprise. Then we have autonomous agents and something to do with game development that I don't quite understand, but I'm hoping to understand it when James talk about it. But all right, let's get started. Let's welcome our first speaker, Lucy from Upstage AI.
Okay. Very nice to meet you. I'm Lucy, and today I'm gonna tell you about a very accurate and powerful LLM that we're building here at Upstage. So I want to ask one question. How many of you heard of solar? Anybody? Oh, we have one. Oh, thanks. Have you used it? Ah, I see. Very nice to know. Thank you for reading it, though. So after the session, I hope everybody will be aware of Solar. We're really proud of this very small LLM that we're building. Our focus is to build a very affordable LLM. We don't want everybody to go for $7 trillion. We want LLMs to be affordable, be available to everybody. So that's why we're working on this particular sector of the market. So let me tell you more about this. So if you want to access to the slides, you can actually take a QR code here. It not only has the link to the slides, you can also get free API access to Solar as well. So if you're interested, I'll give you about 5 seconds to take a photo of it. All right. So let me give you a brief introduction of myself first. I'm Lucy. I'm currently, I'm a co-founder of Upstage, and currently I came here to spread the word of Upstage to the US market. We're originally based in the South Korean market. We have huge customers like Samsung, LG, you know, those big brands. Yeah, and but we want to make this affordable LLM available to a lot more people, a lot more audience. So that's why we came to the US. And originally I'm an engineer at heart, and I built AI products from the beginning of my career, still building it as a product manager. And yeah, that's why I'm here. Sung Kim couldn't join us today, but yeah, that's us. So, and you are all interested in LLMs, right? Everybody is. And I think a majority of the LLM community is very interested in RAG as well. At Upstage, we're also interested in RAG because not everybody has the right conditions for actually fine-tuning an LLM. And a good alternative for that is using RAG. And not only us, it's not only us. A lot of people are interested in that RAG. And we kind of noticed that within the community here. So here are some pictures that we actually took from workshops like this. One is from Bento ML, one is from Llama Index, one is from LangChain, and everybody just wants to put in data, parse that data into LLM-ready documents, and then use an LLM to do Q&A. And we are also interested in doing RAG with LLMs, but we noticed is that there are 3 problems that we really want to tackle. So when you're actually trying to use an LLM for QA purposes, it is quite slow and sometimes very inaccurate. And by saying inaccurate, it tells you a lot of lies as well. So, but when using Q&A engines through LLMs, we don't want our models to lie. So we kind of wanted to address that problem and thought of ways that we can actually tackle that problem. And another is when you're actually asking an LLM questions, you kind of want to condition the model with documents sometimes, a lot of times actually. A main use case for us is, like, for example, insurance companies, they have a whole lot of documents within their company. They want to input that documents because sometimes that document is very long and customers don't want to go through that whole document to understand, like for insurance claims and so on. So we want to input that document, but sometimes that document is very, very complex. So it's not just text. It has tables, it has figures. It has a lot of visual cues. So LLMs have quite a hard time to understand that context. So at Upstage, we kind of wonder how we can input those unstructured documents and send it to LLM so that it can answer our questions properly. So we address these 3 problems with 3 solutions. So first is we want our LLMs to be fast. And also when it's enhanced with RAG, we want it to be powerful. And then we also want an answer verifier because, as I told you before, LLMs tend to lie. And then finally, in order to understand unstructured documents as well, not only raw text, we also wanted to understand documents. So we also add a layout analyzer to our stack. So let me just get rid of that. Okay. So to dig into the details of each of these 3 bullets, let me just show you our Solar LLM and how it's and its speed throughout through generating a response. It currently works at 50 TPS with an A100 machine, and our customers are very satisfied with the speed, and it can be fast because it's so small. It can go faster when we actually integrate the LLM into a purpose-built machine, probably something like Grok. And when it's enhanced with RAG, it also goes very powerful. So this is the results from a couple of days ago. We were surprised by the results ourselves, but because we didn't know somebody was going to enter a competition with Solar, but somebody did. And they actually ranked first place within this competition. So down is better in this table. It's kind of awkward, but yeah, it's at the bottom of the table, which is good. But so these guys use Solar, they integrated RAG and won first place in the conversational multi-doc QA competition held by the Wisdom Conference, which many of you might know. It's a very big conference for data mining. Yeah, so we have a powerful LLM in our stack and which is affordable. And we also have our layout analyzer. So to let you get an idea of what our layout analyzer does, I brought you a sample image. So here you can input any random document. Perhaps that document has a lot of visual cues inside. This is a sample of where we have a visual representation of Upstage. We send it to the press and stuff so that they can, easily send out articles about Upstage. But it kind of looks like a table, right? But if what would you do if you have this kind of information and you want to QA? on. Normally, you would have a long document that you want to QA on, but I'm sharing this short example just for presentation purposes. But your document probably has so much visual cues like this, right? What would you normally do? You want to ask an LLM about your document. Some people tend to use OCR. A lot of people use OCR actually, but OCR engines are specialized in reading bounding box, reading text and text segments alone. So those text segments don't really come in a human reading order. So if you just naively use an OCR engine, it will read about Upstage, founded, services, founder, fifth, solar, LLM, and so on, which doesn't make any sense to a human. But with LA, what we're trying to do is we're trying to structure that information into a natural reading order so that not only humans, but also machines like LLMs can understand the whole context of visually rich documents. And because we're putting text into reading order, of course, the Q&A results are very good. So like without LA and with just naive OCR, if you ask how much Upstage has raised, it doesn't know the answer. I mean, it says Upstage has raised an undisclosed amount of money, but it was obviously in the document, right? But with LA, it answers correctly because it has structured data within the prompt. So we kind of benchmarked Upstage LA. We just released a beta service and we're just entering the market, but there are some other players that are entering this market as well. So we have, of course, Google, Microsoft, AWS, and some other open source and startups that are entering this market, unstructured market, Nougat, and so on. And we're currently here and we have this model that we're releasing at the end of March and we're trying to go here. So if you see the axes, the y-axis is accuracy and the x-axis is speed. And so we're prioritizing accuracy over speed at the moment. So we're pushing this up to about 90% accuracy. We're seeing about 92 accuracy for our next model. And then we're going to go tackle speed and process like a 100-page document within a minute. So yeah, that's where we're going now. And finally, we have the answer verifier, which verifies whether your answer, whether your response actually makes sense, actually complies with your input document. So this isn't a fact verifier, which says whether who's the current president and saying whether it's right or wrong. It checks whether the answer actually matches with the current document that you have. So yeah, with this answer verifier, you input the context, question, and answer, and you will get the output saying, yes, this complies, no, this doesn't comply. And it actually is based on an LLM as well. So those are the 3 ingredients that we have. And what we do is we actually made a demo that combines all these together and gets input a document, and then you finally get a question answer machine. So let me just quickly show you how it works. So this is a paper that we input. The original paper is here. It's the solar paper. And it is a 2-column paper. So if you just do OCR, it's gonna output gibberish, but we want our model to read the first column and the second column in order. Oops, sorry. And we also want the images to come out correctly. And of course, tables, because tables are a very important source of information. We want it to be parsed correctly. So So after we do layout analysis, as you can see here, the tables come out as HTML tables. The sections all get merged correctly. And there are some images that are input and so on. So if you ask a question, say, what is thus? So the title is depth of scaling. So I will ask what it is. Yeah, it says, so thus is the depth of scaling. It is efficient and effective, and so on. So if you were to make this demo for yourself, it's very easy. It's very, very easy, actually. So I will give you a brief introduction throughout the code. So I told you 3 ingredients: LLMs, layout analyzer, and verifier. So all you need is these 3. The first comes out here. So we're building a function named Ask Solar. And you might be surprised seeing OpenAI here. We're using the OpenAI SDK because we know that a lot of people are using OpenAI, and it's compatible with OpenAI. So all you have to do is replace the base URL with the Upstage URL, and you can just use it right away. You can just reuse your previous code. And so you open up a client, and you get the response by inputting the model, the messages, the question and content, and so on. And then the layout analyzer is as simple. I mean, you just input an API key, which I will give you a complementary key further on, and headers, files, URLs, and response. It's just a very simple HTTP request. And finally, the verifier, which will come out in March 14th, which isn't very far away. You also send a request similarly to the LLM. And then finally, so since you had the 3 ingredients, you just have to merge them together. First, you send your content to the layout analysis function, and then you ask Solar, and Solar will reply. Sometimes it will tell you a lie, sometimes it will tell you the truth, and you just iterate until the verifier says, okay, this complies with the document. And then your client, your customer will probably get a reliable answer. So I told you about building a QA machine, a RAG machine, but you can also do summarization, writing extensions, agents, build agents, and so on. And there's so many capabilities, and we'd love to talk with you and discuss how you can use Solar. We're very interested in expanding the community that uses Solar. So if you have any questions, you can ask me about them. And these are the API keys that I told you before. You can get access to the slides here. It's very simple. Upstage Hackathon token, you can memorize it. Otherwise, you can just take a picture and go use it for yourself. For Solar, the beta access token will be just at the console if you just log into it. So it's particularly easy. For LA, you'll have to use this token. All right. And also, this is the last section that I wanted to tell you. We have a Solar LLM Innovators Award. So as I told you, we want to expand the community. We want to help developers get access to affordable LLMs and let them build very powerful applications. And so we're doing this Innovators Award, and we're sending out 200K USD credits by March 31st. So if anybody is interested in building applications, you are welcome to join us in this exciting journey. Okay, and that's my presentation. Thank you all for your attention.
Any questions for Lucy?
Great presentation, thank you. Does the layout analyzer work on raster image files, or is it actually using the PDF data to build the layout?
We definitely include images.
Great. Okay.
Images are a very important source because not all PDFs have text embedded in them, and we realize that.
Great, thank you.
Mics are
Thank you. My question is, well, I haven't checked the Hugging Face leaderboard yet, but I'm wondering, like, what's the general capability of Solar compared to like a SOTA ones like, I don't know, Gemini, Ultra, GPT-4, or for, I guess, language capability, or yeah, that's kind of like what I'm looking at.
I think somebody else has the answer for you because we had a tweet today mentioning Solar and somebody benchmarked the capabilities. So if you see here, this guy benchmarked against Mistral, Solar, Gemma, DeepSeek, and so on. Currently, it seems we'd have to benchmark for ourselves as well. Yi is leading in the mean score. And Solar is, I think, third here with a very small gap with Gemma. But what we saw from this graph was if you go to the English mean score, Solar is achieving the highest score. So it's very good at language.
Hey, thank you for your presentation. I had a question about the verifier. Is the verifier another smaller model that's checking the Solar model, or is it some heuristic-based post-processing?
Very good question. Actually, it's not a separate model. It's the same model with Solar, but it was it has prompting inside. Yeah.
So then you can say that the verification is capped at the capability of the verifier.
Right. So yeah, it's probably gonna improve in other ways, particularly getting smaller, because obviously for verifying it, you don't really need too much capabilities. It's a very small task. So we're probably gonna work on the economical gains.
Yeah. All right, thank you. Sorry, a few different questions. One is it bound by is Solar bound by context size? And if so, can you process documents that are bigger than the context size? Second question is you mentioned Upstage, which was able to process table data. I was wondering if you have any comparison with Llama Index. They had a recent release to do the same thing. The third question is, do you have any code examples you could share that's on GitHub or anything? Thank you.
So the first question is the context links. It's currently 4K for our open source model. And we're looking into increasing that. But we're kind of balancing, we're trying to investigate the differences, investigate the strength of RAG and a longer context model, which will be powerful in what kind of use case and so on. So we'll have some updates on that, but currently it's 4K. And about Llama Index, I think you're mentioning Llama Parse. Is that correct? The second question, yeah. Yes, we've actually done a benchmark, and I think it's up to you to decide. But for us, I think we were strong in this market. And the third question was, GitHub code. We have a repository at GitHub, upstage examples. So you can probably find some examples there. And we also have a developers document, which also contains some examples.
We have one more question here.
So thank you very much. It was very interesting to see this layout analyzer approach. And this seems to be kind of like an original approach to RAG, right? So I was wondering, with respect to like chunking text and then doing like a vector search and maybe re-ranking on top of your results, how do you see these things like working together with respect to the layout analyzer? Like, do you think like the layout analyzer can be a substitute for that, or is it like something that you can work, like, you know, you can have a more complex system working with also like vector search and everything?
Right. I think rather than it being a substitute, I think it'll be a very good complement. I mean, so you have to input the document, you have to convert the document, a visually rich document, into LLM ready text data, right? And then you can chunk, vectorize, embed all your contents so that it can be searchable, re-rankable, and so on. So I think it will, layout analyzers will work as a pre-processor for a lot of LLMs.
Okay, we have one more question and
Thank you. So I want to ask about a question about the, verifier. So you said that it's part of their model. Does it share, the weights with the, Solar model, or is it a separate component that doesn't share the weights of the, Solar large language model?
For now, it shares the weights. But in the future, we're planning to update it so that it becomes separate, much more economical, much more lighter.
But if it's just the same weights as the model, is it skewed or like biased towards, saying that whatever the model outputs is correct?
That is a very good point, and that is exactly why we're trying to split the model.
Got you. Thank you.
thank you, everyone. Huge round of applause for Lucy. Thank you. All right, who's ready to hear about agents, autonomous agents? I am eager to hear about it. Let's welcome Eric from Brex. Okay.
Testing. Sweet. All right, what's up, folks? Just before we get started, I'd love to just do a quick poll of the audience. Who here has worked with agents before, like played around with LangChain? I'm not going to call on anyone. I just want to get a general sense. Sounds good. And then is there anyone like non-technical here, like haven't written a line of code in sales? Sweet. Just a small handful. But I promise I'm going to keep this presentation. Try not to go too in the weeds here and make this pretty digestible so that all skill levels can understand. The goal of today is, I feel like agents are everywhere these days, or at least that's the talk of the town, right? It's always agent this, agent that, like agents are going to take over the world. So in this presentation, what I really want to do is, one, demystify what the heck actually is an agent. And two, see if we can actually build one from scratch. And you'll notice actually, it's not too complicated to get a basic agent working in just a couple lines of Python, no LangChain or any libraries required. So I guess I should introduce myself too. A little bit about me, full stack developer. Most recently, I've been working at Brex, which is a corporate card and expense management software company. on the AI team, and I like to say that I get paid to play with ChatGPT every day. So without further ado, let's get into it. So it's sort of hard to believe, but ChatGPT, that came out like basically a year and a half ago, and think about how much has changed, right? We've got all these big foundational models popping up, LLMs, completely transform a lot of people's workflow. And naturally, with this sort of transformational generational technology, the question arises, like, are we still going to have jobs with all these super smart AI, LLM, and things going on, right? And to be quite honest, while that's probably not going to happen, in the next year, maybe 2 years, it's very plausible as these models get better, as they get quicker and cheaper, as we really learn how to use them the right way. It's not out of the realm of possibility that we just have these quote unquote AI agents, which basically replace humans. Like already today, we have agents which you can tell, like, build me a web app for my drop shipping business, and it'll go out of its way, write all the tests, write all the code, test it, make sure that it works, deploy it, and get it working end to end. And it's really pretty crazy the amount of stuff that we can already do with the existing LLM tech out there, right? So how do we actually get to this world, though, of AI agents replacing humans? Well, for one, ChatGPT itself is not the equivalent of agent, right? Like, yeah, you can ask ChatGPT to write you some lines of code, but it can't do everything that I talked about before, which is like the rest of the stuff, like all of the testing, like complex decision making, right? And the main reason for that is because there's two main limitations with just a standard off-the-shelf LLM like ChatGPT or Claude, right? One is, as you guys probably know, they don't have access to information outside of their training data, right? So if something happens in the news yesterday, LLM has no idea that happened, right? And the second thing is, probably more importantly, an LLM itself can't interact with the outside world, right? It can't like click on a button or access your file system or write to CSV, right? So these are the two main limitations that we need to solve by developing agents. So if I were to ask this thing, like, just ChatGPT, order me a pizza from Domino's, it's going to say, like, I'm just an LLM. I can't do that for you. So how do we actually build an agent? We know that LLM is the core technology behind it, and an LLM by itself is really, really powerful. If we think about an agent in sort of analogy terms, right? The LLM can sort of be like the frontal lobe, which is responsible for reasoning. It takes in sensory inputs, decides on an action to take, right? All that the LLM is missing to really create the agent is one, eyes. It needs to actually be able to see the world or see the things that it needs to interact with. It needs a way to actually interact with the world, right? So sort of like a body. And then three, it needs some sort of memory to keep track of actions that it's already done. And if you have all three of those things, you got an agent. So without further ado, let's get into it. Let's just start getting our hands dirty, and let's try to build an agent that orders a pizza from us from Domino's, right? One thing that we could do is we could use either LangChain or Llama Index. I love both of these companies. What they're doing makes developing agents, RAG, so much easier. But I think to really understand what's going on behind the hood, we need to get past all those abstractions. So let's see if we can try to do it from scratch. So let's get started. Okay. Sweet. And also, while Lucy was talking, I wanted to see if she was telling the truth about the Solar beta being available, and I can confirm wherever you are, super easy to get set up. Got the token ready. We've got Call Solar. We plugged it in, so we're going to use Solar as the LLM that's powering our little demo today. Right. So let's just get started. See if it's still working. Oh. So I've just got this little wrapper method, Call Solar, and there we go. We've got an assistant or chat LLM ready to go. Okay, so what's the goal here? We want to build an autonomous agent that can browse the web. So think about you as a human. If you can do something on a website, like post something on LinkedIn, read some articles, order a pizza on Domino's, this agent should be able to do it for you also, right? So the task that we're going to focus on, at least in this demo today, is order a large pepperoni pizza from Domino's for me, right? And that's the task that I've got written out right here, saying, please order me a pizza to this address in GitHub. So the way that I'm going to approach this demo is we're going to try to build this thing iteratively, right? We're basically just going to keep on calling an LLM, see what it outputs, and just keep on improving until we actually get something that's working end to end. So yeah, let me zoom in. Sorry, one sec. It's always finicky. I should do this. What was that? Pretzel Plus doesn't work for me for some reason. All right, is that a little bit better? You guys see? Okay, I can try to do one more time. Is good? Okay, cool. Let's just see if the output is readable. Oh yeah, perfect. The output's good. Okay. Yeah, so this is where we're starting. This is our first prompt that we're starting with. Very basic. I'm just giving it, some priming it, saying that it's a helpful assistant that can use the browser on behalf of the user, and its task is to order me a large pepperoni pizza to deliver here, right? And then, so this is in black is the prompt, and in green is the output from Solar, right? And what does Solar tell us to do right now? Oh wait, actually, I'm not actually using Solar. Give me a second. Okay, cool. All right, sweet. So this is what Solar thinks, just with this very limited context that we should do, right? The most logical next action to take be to navigate to the order section, start the ordering process, right? And you see maybe it's hallucinating, maybe this is actually true that the order button is in the top right corner of the page, right? But it's not in a good state right now, right? We need to give this agent more context because right now it doesn't actually know what the HTML looks like, what the website looks like that it's trying to interact with. So that's the first step is let's give this agent some eyes, right? So if we go, if I were to just go to Domino's.com, I as a human, obviously I can see, the layout of the web page. And nowadays we have multimodal LLMs, which you can actually pass an image as well as a text prompt to, but those are expensive as hell and also aren't really good when they're not fine-tuned for a specific purpose. So something generalizable that we can do that works with any just pure text LLM is just really pass in the HTML backend representation of this web page into the LLM, because all these foundational models have been trained on lots of HTML data, so they understand how to read that markup structure. So effectively, this is our way of giving the agent eyes. It's by literally passing in whatever HTML is open currently, and the LLM is actually pretty good at understanding the layout from that HTML. So in this second iteration, if we run this, here's the new prompt, right? It's the same as before where we say we have a new task and we have this web page that's open, but now we're actually passing in the HTML of the current web page, right? And just to make this demo a little easier, I have this dummy, very simple HTML so that it doesn't hurt anyone's eyes with a lot of ugly tags. But in this very simple HTML, there is, a header and a button that it can click on with an ID of order button. So let's see what the LLM wants us to do now, right? Now that it actually has eyes and it can see the HTML, it does some reasoning, and look, it actually tells us, oh crap, we can, call this function to click on the order button, which is super interesting. I have the wrong system prompt in here. One second. it's saying it's using Playwright right now, but that's not exactly right. Sorry, bear with me. But I will say I appreciate how fast Solar is. This is awesome. Yeah, so back to where we started, right? So it's saying based on the HTML contents, the most logical next action is to click on the Order Now button. That's perfect, right? And like, if I were a human, that's the exact next step that I would do, right? I would see this order button element on the GUI, click on it, right? So that's pretty good, but it's still kind of annoying right now because it's very possible that the agent just spits out something random, like draw something on the screen, right? It doesn't actually know what it's capable of doing. So the next step is to actually tell the agent explicitly the actions that it's able to perform, right? So if you think about you as a human, what are the actions that you perform on a web browser? It's actually pretty simple. And when I was thinking about it, it's like pretty shocking how basic the input mechanisms are when we're using a web browser. Like basically all you really do is you click on things, you type text into inputs, you choose drop-down values, and once in a while you'll navigate to a different URL. And to build like a functional web browsing agent, that's really all you'll need. It's just these 4 different actions. So you can see here, these actions sort of look like Python. They take in a specific argument, and I type it for the agent to understand. So now if we actually pass this into the agent, what just happened? Oh, I didn't run the cell. Okay. So now if we actually pass this to the LLM, here's our new prompt, which is now getting a little bit beefier, where we basically tell the LLM, here's your task, here's the actions that I want you to perform, or here's the action that you can perform to complete the task, and then here's the web page. And then check this out. So now that we've actually scoped the LLM to a specific set of actions, it correctly picked that if I want to click on the Order Now button, I would call this action called click HTML element and supply an ID, right? So, and if you actually look, it didn't hallucinate. It's calling the click HTML element function for the ID of order button. So wonderful, this is awesome, right? But as a developer, we're still just iterating on this in a notebook. But as a developer, this still isn't very useful to me because it's not something that I can reliably parse, right? The thing with LLMs is they just generate lots of text, right? We now want to be able to actually scope, we now want to be able to enforce a structure on the output of the result from the LLM. And one thing that LLMs are really good at doing is generating JSONs, because that is the basically language of the web. So to ask the LLM to generate JSON, we basically have to define a structure that we would want, and then just tell the LLM, make sure that your output is in this response. So you can see I keep on adding to this prompt here. This is the same old prompt, and I've added this line here. Your response must be in a JSON format with a field name action, where the action has this structure, right? I keep on making the same mistake. So I always want the LLM to respond with a JSON that has this field called action, where the action is called in this specific format, right? So I can always, as a developer, reliably parse the output of the LLM. So let's see if the LLM did its job. And there you go, perfect, right? Like now you can start to see it's sort of slowly starting to come together, right? So that's great, right? And basically at this point, we have a working agent somewhat, all right? This is like one turn of an agent. So imagine just throwing this thing in a while loop, piping in the current HTML, having the agent select an action to do, calling that action, waiting for the HTML to load, rinse and repeat, right? That's an agent working already. It works fine in our pet example, but we need to make this thing more robust, right? Because all in all, agents, LLMs have a tendency to just hallucinate, and it's at the end of the day, it's just like a next word. It's really good at next word prediction, right? So the bigger your HTML gets, the more likely that the agent is to make stuff up, like make up an ID or make up an element that doesn't actually exist there, right? And one way to solve that problem is to actually ask the agent to think and observe the HTML before calling the action, right? So that's exactly what you would do as a human being too, right? Like if I go to dominoes.com, right? And my first step as a human is first observe, right? I need to observe, like figure out what are the important elements on this web page that I want to click on. I'll notice that, oh, there's a delivery button. That seems like it's relevant to my task. So basically what I want the agent to do is also to go through this thought process first before making up its mind and taking that action. So that's why in this better JSON structure that I have here, we're actually telling the JSON to first observe the page. So explicitly identify the important elements and describe like the purpose of the page, right? Just to give itself some grounding in what's going on. And then the second thing is I want it to perform some reason. So basically think out loud, come up with a game plan and make sure that whatever action that you choose is logical. And then only then after observing and thinking, can you actually call the action? So this is going to make our agent perform a lot better when we have a lot of context and very heavy HTML that we need to pass to the prompt. So let's see what happens here. So again, we're still on the same exact, using the same exact dummy HTML, but now the agent not only returns the correct action, but also returns observations. It correctly identifies that this is a web page with like headings and menu prices, and it also conducts some reasoning. And also just, I see some people taking pictures. I'll share I have the link to the notebook and the code at the end of the slide. So don't worry too much if you can't get the pictures. Yeah, so that's basically it as far as a very simple agent goes, right? And this is, what I just showed you guys is basically what's called the React agent method. So reasoning and acting, right? And that's basically the core of how I'd say any agent works these days. Is you ask the agent to think first, and then you ask it to choose an action. And you just really need to do some plumbing to make sure that the output is in like whatever format that you can parse as a developer to actually write the code to do that. Now, the last step is you might be thinking, yeah, now we're ready to actually plug this thing into a while loop, right? Like just have this LLM being called with the new HTML. The problem with that is, if you remember back to the slides, the third step or the third part of building an agent is memory, right? Like it needs to know what it has done previously in order to guide itself on what it should do next, right? Because if you think about it, like, let's say the agent, let's just get started, like, let's say the agent has, made it all the way through to the delivery. Like we just go like 75 Brannan Street. So let's say this is just pretend, bear with me, that the agent is doing this and not me. So let's say the agent has made it all the way through to this step and has added a pizza to the order, right? Now, if we were to get the HTML of this page, there's a lot of stuff in here. And you'll notice that there's like a one item in cart element here, right? And that just matches up with, where's my browser? This one element in cart over here, right? But if the agent didn't have memory that it just added a pizza to the cart, it's gonna still try to keep on adding more stuff. And it's very possible with like these huge HTMLs that the agent will like even though there does appear to be a pizza in the cart, it's very possible that the agent's just going to gloss over that and try to keep on adding a pizza to the cart. So this is the part where memory becomes very important, right? So now I'm going to try to stress test our LLM here and see if we give it some context about the previous actions it's taken, right? Like you have already entered your delivery address and added a pizza to the cart. It shouldn't try to like say we should click on add pizza to the cart order. It should say we should go directly to checkout, right? So let's go to let me run this cell. So I have the simplified HTML, this text, big text blob stored in that variable. And then let's see what the agent decides to do. So you'll notice, this is some really complex HTML, and I don't know what just happened. All right, so it might be an issue with, bad request. I don't know, maybe the API is down or something, but you get the point, right? It's like the agent needs memory so that it doesn't repeat tasks and it has context on where it is when deciding the next thing to do. So I think I have like 7 minutes left. So I think I'm going to take a pause here and just ask if there are any questions. Yeah.
It's actually encoded in the image instead of in the HTML code. So with that being said, if you don't have the image, then the agent won't be able to know what to do. Let's say that the agent is going shopping and there's no like textual description of the shops, of the items. We only have the the images of each item. Then in this case, a pure text-based agent won't be able to do anything.
That's true. That's a really good point also. The thing is, with a lot of the like most common sites, they'll have in the HTML like screen reading tags, like they're called aria dash something. So they're effectively descriptions for when like, for basically blind people, for like what's on the, like what image is actually present, right? So the agent would actually be able to read like, oh, like this data queue ID is like loaded tots or something, right? Or like, let's see this image. Like image tags sometimes have an alt where you can tell like a developer can say like, this is an image of pizza. And this is what would render if like the image source got deleted, right? You see, like that's all, but I totally hear what you're saying. And I think this is where like, again, multimodal, much more powerful LLMs would be able to handle this problem more effectively, or even like use Lucy's layout analyzer, right? Like feed that into the like generate some sort of structural representation of the image. Yeah.
Anybody else?
Have you tried, what's the difference in accuracy when asking it, describing the JSON structure and using the function calling?
So I actually haven't tried function calling. My point with building this or this demo was to try to not use any like, basically try to make it as generalizable to just any LLM as possible, which is why we could like plug into Solr, right? Like I'm not sure if Solr does function calling, but I'd be curious, and I can get back to you. I'll try it out. So let me get back to the demo. So we did a lot of just screwing around in a notebook, but I actually implemented the code, which is like not that much. It's not that, I don't think, important to go over in detail. Again, I'll share this in GitHub, but under the hood right now, it's basically implementing that while loop that we talked about beforehand, right? So I'm basically telling this agent, order me a pizza to this address, and it's just doing thinking now on the actual raw HTML. And you'll notice the HTML that I pipe in is actually relatively small considering an HTML. What I'm doing is a lot of pre-processing, like getting rid of unnecessary tags, getting rid of hidden elements to really try to condense the HTML and get rid of any unnecessary tokens that we don't need. But you can see it's going on its merry way, and under the hood, it's not using Solr right now. It's using Gemini Pro. You know, you got to give Google some love. I feel like OpenAI, everyone's just using ChatGPT all the time. But yeah, it's using Gemini Pro right now, and I don't know if the demo gods have blessed me today. I need to play around with the temperature because the temperature of the LLM can dictate how creative the agent gets. So it doesn't look like it's working right now. So let's just restart it and pray that in the last 3 minutes it can order us a pizza. But any other questions?
So one of the classic problems with web agents is that like they have to know the syntax of the HTML that they're talking to. Thanks. So I'm wondering if you can foresee a point where you don't have to give it the HTML, you can just tell it to look at it like this is a button, it says order, not caring about where it is in the DOM, not caring about what the name of the HTML element is. It just literally tries to use the page off of the LLM instead of you having to kind of prep it with HTML.
I think that's a really great point. Yeah, it's just that works well for websites that have basic components that aren't duplicated. But think about like if you go to like a LinkedIn, right? Like there can be like 50 like buttons. So like how do you differentiate which like button to the agent, right? It's like at the end of the day, I think the easiest thing is still always just pass in an HTML that has the true representation of the document and just pray that the foundational LLMs get good enough to solve it. Yeah, I did not get blessed by the demo gods today. I don't know what's going on. Oh, it's going. How about let's click on delivery and like let it see if it can do some stuff. It's thinking Gemini Pro. Oh, there we go. Okay, so it filled out my address if anybody wants to dox me. And yeah, it's going to try to order a large pepperoni pizza. So again, it's just using the same exact stuff that I showed you in the demo, just running in a while loop with a bunch of extra parsing in the hood. So I got like 1 minute left. Let's see if it chooses to cheese it up. I'm actually very curious. Oh, it chose not to cheese it up, I think. Let's see the reasoning. Yeah, it said no thanks. Okay. I guess Sam Altman doesn't like cheese, or maybe he's lactose intolerant. But I think that's my time. Here's the link to the GitHub repo if you guys want to scan. Yeah, I really appreciate the time, and I would love to chat if you want to work on this just for fun or anything.
Thank you, Eric. Thank you so much for this great presentation. Give him a big applause. Thank you so much. Our next speaker is James from Saizo.
Great, thanks.
Hello? Those were a couple really impressive talks that are hard to top, so don't hold your breath for this one. Hello, everyone. Yeah. Oh, here's Mike. Okay, cool. Hello? Push. Hello? All right, cool. Good evening, everyone. I'm James, aka Saizo. Today I just want to talk about something I made. So back in February, I launched a small browser game. It's a tiny JRPG that takes you on a journey in the story of the Iliad, where you have a chance to alter the fate of Achilles. It's like any other JRPG game you've played, albeit a bit shorter. But I think what's special about the game is that it's fully, well, almost fully created with AI-generated content. Not only that, the conceptualization ideation process was also heavily influenced by AI. And today I'm going to dive into some of the pros and cons of using AI to assist the creation of a game like this in this session of game making with AI. And before we start, let me show you quickly what the game is like. In the next slide, I'll show you a combat scene of the game, just so you know what you're getting into. So this game deliberately takes on a 2000s JRPG tone, so you can judge for yourself how this looks and whether you want to give it a try. But do keep in mind that everything you see here, except some of the animations, is created by AI. So if you want to try out the game, you can scan this QR code, and I'll keep this QR code on all the following slides just in case you want to scan it later. But I highly recommend saving the URL and playing it on your laptop because it works a lot better with a mouse cursor. That being said, let's first talk about what AI is good at in game development process. So, by the way, don't be scared. Again, I know Sana said she didn't understand it, but don't be scared because I really didn't do anything special or fancy. I just kept talking to ChatGPT and tortured it into generating different parts of the game for me. So, I think most of you can already guess that AI can be used for story generation and asset generation, but you might be surprised that AI is actually really good at ideation too. Is it? Oh, okay. They said they're going to charge me a fee to, I'll give you a new one at the end. So what do I mean by that? So in the beginning of developing this game, I only had, well, you know what? Let me just go have a, give you the, sorry. Let me just give you the, give me a second. I don't know. I don't know if that's clear enough, but I'll give you the link in a bigger font at the end. So, okay, so ideation. What I mean by that? So in the beginning of developing this game, I only had some faint ideas. I just finished reading the Iliad, and I was fixated on creating this game based on Achilles' story because the struggle against fate just left me pondering for a long time. So I asked ChatGPT to give me a summary of Achilles' story if I were to create a game about it. You can see this is the basic structure that ChatGPT gave me. You can see here that ChatGPT sort of went off the track to start designing some of the quests already, like the third one, diplomatic mission to Achilles, which I didn't end up taking, but there was a ideation process that it can do with the ChatGPT. So it's really helpful, and it really gave me a structure of the important points of the story, which helped me eventually condense the story into 2 branching points and 5 dungeons. At this stage, I wasn't quite sure what I was going to create yet, but going back and forth with ChatGPT really helped me drill it down to a final idea. And so I went on to the story generation process. So I just basically gave ChatGPT a few prompts to let it generate parts of the story. ChatGPT was also very good at generating a story in my specified JSON format, and that's a huge help, as I just didn't need to write anything now. I can just feed that directly into my game engine. Once you have ChatGPT generating more of the story, you soon realize that it always just sort of follows a very recognizable formula and does not have many variations. It's always going to generate paragraphs of a certain length, and it's always going to generate a certain number of turns of dialogues, give or take. I'm sure there's more work that can be done here to create more variety, but for my short game, this was kind of enough. And in terms of asset generation, ChatGPT mostly does a good job at generating story scenes and combat scenes. But I think that's partially because I happen to not have a super high requirement for these scenes. I use ChatGPT to generate every static asset in the game, including characters, monsters, and on the right, there's an oracle card that you sort of encounter to level up your character. But there are things that ChatGPT is not really good at generating, and we'll look at some of these examples next. So I'll go over some of the challenges I faced when creating the game with ChatGPT. The first is in creating characters with character, so to speak. So this, I think there are some solutions, but I haven't tried out. But even though all of the characters in my story have an origin, and technically ChatGPT should be able to dig into the Iliad to give the characters more polish. We've seen that it's not really doing that, at least very obviously. So most of the characters basically sounded the same. The second challenge is animation, and I'll talk about this with music and sound. So in this game, the only assets that are not made by ChatGPT were animation, music, and sound. I've tested multiple different tools, and some of you know Google has a music FX, but that doesn't really work that well. So besides ChatGPT, none of these tools are very satisfactory. So in this game, I put together the animation myself, and I sourced the music and sound elsewhere. So I hope this field develops more, at least for music and sound. I think Transformer is very promising, and someone just needs to get the user experience right. So let's continue on the asset generation again. I mentioned that there are some assets that ChatGPT wasn't really good at. Well, when I'm talking about ChatGPT, it's really DALL-E 3 behind the scenes. So there are some assets that the ChatGPT is not really good at generating. So I'm going to show a couple examples. So the one on the left here is an image generated by ChatGPT when I ask it to create an UI for the shop in the game. So ChatGPT actually generates several versions like this, and apart from the random letters and the unnecessary background, the proportions are also nearly never right. So the picture on the right is one of the enemies generated by ChatGPT. And while this enemy itself is looking decent, as you imagine, I have to do a lot of photoshopping to carve it out. And this happens consistently with every other enemy that's generated. So overall, if you want to design a game with the help of ChatGPT, you still need somewhat decent photoshopping skills. And even then, the process is still very time consuming. So with that said, so that's the short version of my experience and challenges in developing Achilles, Genesis, Invictus. And by the way, if you haven't noticed, it abbreviates to AGI. Happy to answer any questions here and offline. You can also follow me on LinkedIn and Twitter. I hope that Twitter thing also works. Maybe not, but let me know if it doesn't work. And last but not least, I've built chatbots and advise startups and business owners on integrating AI into their products. If you're looking for answers or solutions, I'm here to offer a free consultation. Thank you. And let me just update this with the link to the game so you can have it as well.
Thank you so much, James. I appreciate it. Let's take some questions if you guys have questions. All right.
Hey, thanks for your talk. Can you talk about the music, the audio side of things, and just some of the problems you had, some of the difficulties you had with ChatGPT, I guess, or AI in general, creating audio?
Yeah, so I tried a couple of different things. I think so at the time I was doing this, so music came in much later. So I didn't look into it as much as art pieces. But when I was trying to generate music, so I looked into Music FX. It was developed by Google. I think there was maybe one other solution. I forgot the name. I think there was one more thing that I tried that was developed by another big name. I forgot which. But so, but I remember Google's example, right? So it basically, it's the functionality is very limited. You have to tell it exactly the style you want, and then it pops out like 30 seconds of music clip. And the music is also clipped at the beginning and the end. So you sort of have to do a lot of audio editing to get it to work. I was also trying to like give it a reference of like create a music like this music, right? It doesn't really work. So I sort of just gave up at that point. You know, and for sound effects, I don't know if I can't remember if I tried, but I just figured, you know, getting doing a like a paid option for like a month, like a monthly subscription was just like a lot easier. That way you can get the sounds than, you know, trying to figure this out to see if there's even a solution. So I hope that answers your question.
Just to follow up, was the quality okay, or was it more just like the user experience? Because you kind of mentioned the user experience was kind of the main problem, but was the quality at least decent, or maybe that even wasn't good enough?
Yeah, I think you're right. I think the quality was also not ideal. So, you know, I have my own basic like MP3 store. So which, you know, for this project is free. I'll make it available for free. So I just sample some music there. But basically for Google's generated music, there's kind of some noise there. I think you're right. And then I mentioned user experience basically because I really hate to be giving it the different styles, because even though I think what is gonna generate based on these styles, it might really generate the music I want. So I'd much rather have a model that remembers the styles from other pieces of music. And then I would just say, hey, give me a music that, you know, sounds like, say, Lion King, right? And it would just give me something similar to that.
Thanks.
Yeah, thank you.
Anybody else? Other questions? Yes.
Did you also get the backend to be created by ChatGPT, or everything?
The game itself?
Yeah.
Good question. Yes. So a bit of a fun story. So when I started developing the game, it was new to me. I've never used a game engine before. I just asked ChatGPT, but I knew I sort of want to create a browser game. So I just asked ChatGPT what's the best tool to create a browser game. ChatGPT said it's Phaser.js. So that's what I started. I just went through a couple examples, but eventually I found it's just way easier to ask ChatGPT to write a code for you. And so that's what I did. I basically, you know, having the fundamentals of how programming languages work definitely helps. So like I was able to understand most of like when it was going in all sorts of different directions. And sometimes the code doesn't work, and I was able to basically fix it myself. And sometimes it doesn't work and I can't fix it. I could basically let ChatGPT help me point. I was like, I suspect this is wrong. Can you like do more? And then it was very good at helping me hammer that down. So yeah, that's, you know, that's what I did.
Thanks.
Yeah.
Very cool.
All right, thank you. I think we're gonna take another question if, all right, there's no questions. One more.
How long did you spend on this?
So the ideation started about half a year before. And I started prompting GPT for a bunch of ideas during that time. And then, you know, it took me a while to sort of narrow down a programming language and then just like getting familiar with it. But I think it was like 4 months before the completion of the game. It was when I got a hang of like how to create the whole thing, and I started really putting things together. And then the last month or so was just like a lot of crunch time. That was, you know, basically getting the assets created and making sure like I do all the photoshopping. So like a really intensive work, probably doing like a double full-time job during that time. So it was, yeah, that's the gist.
Great. Thank you, James.
Thank you.
Okay, this was the last talk. Thanks to all the speakers. I'm going to quickly run the raffle so that I can announce the lucky winners for the wireless headphones. So first winner I have is Mark Van Aken. Is Mark here? Where? Oh, please come on.
Yeah, give him a big applause.
Congratulations. Okay, one more. Ivan Makarov. There we go.
There we go. We have a winner.
Congratulations. All right, everyone, this is it. Feel free to network around. We do have to empty up the building by 8:15 p.m. Thank you so much for coming again and hope to see you on March 14th at Microsoft Office. Have a good evening.